This video is an introduction to industrial inorganic chemistry. The market size of chemical industry in general is really huge globally. It's around $4 trillion for different types of industries. And in the United States, the inorganic commodity chemicals market size is around $40 billion. Also, if you look at the global metal market size, you will find that it's a huge market size. And the main sectors for inorganic chemical industry range between general commodity chemicals production, printing inks, paints and coatings, and chemical fertilizers. In terms of the raw materials, most of these chemical industries use raw materials from nature, three different sources from air. We have different gases that are used for different industries. Nitrogen, for example, is the main component for the production of ammonia, which in turn is used to produce urea, nitric acid, and other products. Oxygen is generally used for oxidation steps and processes in different inorganic and organic industries. Another source for precursors is the sea, which is the major source for water that is used typically for most of the chemical processes, and it's also used for precursor for some industries. The sea is also sold for different salts, for simple inorganic salts like sodium chloride, sulfate, carbonate, bicarbonate, and magnesium salts, and chlorine gas. Most of the industries use minerals from the soil, typically silicates and metal oxides and metal salts for the production of glass, concrete, optics, semiconductors, also for sulfuric acid production. And for the production of metals, it's usually metal oxides and metal salts for production of different metals. The natural minerals for different metals range from the pure element for inert metals like silver, gold, bismuth, copper, palladium, and platinum to simple metal salts, usually carbonates, sulfates, and sulfides. And the major form of metal minerals is metal oxides, which is the major mineral for aluminum, iron, copper, magnesium, and so on. Each one of these metals of interest have a major ore in nature. For aluminum, for example, the major ore is gibbsite, which is aluminum hydroxide. For barium is barite, which is barium sulfate. And for iron, it's hematite, which is iron oxide, and so on. Mining these minerals can be done using different techniques depending on the level of existence of the layer of that mineral. If it's a surface deposit, it's usually easy to just collect the deposit using open cast and open pit techniques, where you just use earth moving machines to collect the mineral from the deposit on the surface of the earth, or even go a little bit deeper using the open pit technique, as you see in this picture to the right here. If the mineral exists at a deeper deposits, it requires underground and solution mining, which is typically done by digging deeper to the underground deposits and either collecting the mineral in the solid form and moving it up for the production, or using the solution mining or leaching by pumping a solvent that is able to dissolve the mineral in the deposit and then pump it up back for collection and production.